Hey guys, in this tutorial we're just going to be doing a bit of refresher on UI stuff, and we're going to be learning a few new controls, and we're going to be making our own editor screen. We're going to have a sort of a level editor that's going to let us place things and possibly add some NPCs, and then add a spawn location and all that. So we're going to learn how to make this little color slider here. This will allow us to color things as we're placing them. And we're also going to learn about radio buttons. That's what these are right here. That will allow us to pick between rigid and dynamic physics for objects. And that's all we're going to do today, mainly just refresher stuff. If you're already really familiar with CEGUI, this is probably going to be a really easy episode for you. So enjoy. Alright, so the first thing we're going to want to do is actually create our button so that we can get into our map editor. So we have the play game button and we have the exit game button already. I'm just going to basically copy this since it's, pretty much the same exact thing, and we're just going to change the position of our new button. So we'll call this the editor button. Editor button, and we need to make sure we change the name so we don't get that crash that we got last time. Editor button. And now for the position, the X is going to be the same. The Y, let's put it at we'll say 0.56, and then let's move down this one to like 0.62. That'll be good. Let's see, we need to have the text say map editor, or we'll say level editor. And let's see, now we want to make sure this is editor button. If you copy pasted this like me, be really careful that you didn't leave anything behind, because it's really easy to screw this up. And now we don't want on new game clicked, we want on editor clicked. So we need a new function for this. I'm just going to go to definition and copy this. So here is in the CPP file, this is on editor clicked, and we need to also put this in the header file. So main menu screen.h, put it right there. On editor clicked, there we go. Now here the current state, so we have this change next, and that's going to change us to the next screen. But right now by default, our next screen, this get next screen index here, is screen index gameplay. We want to be able to pick which screen we're going to go to next based on which button they click. So we're going to change this up a little bit. Instead of just always doing this, we're going to have another variable in main menu screen.h. And I believe this is just an integer. Yep, it's an integer. So we'll say int m next screen index. And we'll start that out at screen index gameplay. We'll just default it to that, though we could set it to 0 or something. And then in the CPP file, whenever they click on new game, here we're going to set it to, just to be sure, we're going to say gameplay, or what is it, screen index gameplay. And then for on editor clicked, we're going to go to screen index, and this is going to be editor. So we need to actually create this editor index. So I'm going to go to definition on screen index gameplay and just add it here. I'll put it as number 2. Okay, and editor. So let's just see if our button appears there. If we click on it, we'll probably get a crash or some sort because we haven't actually created the screen for this and hooked it up yet. But let's just make sure everything works. Here we have screen index gameplay, no identifier. That's right, because we haven't included this in the header file. Let's just do that here. Include screen indices. And since we're doing it here, we don't need to include it in the CPP file. Not that it matters if we do include it in both. Here we go. And building, there we go. Alright, so we have the level editor, and if I click on it, it should crash. It just goes into gameplay screen. And the reason it does that is because I didn't give it the right function. So I'm glad we tested that. Oh, actually, I did give it the right function. We're getting here. Alright, so that's weird. Let's see if this, let's put a breakpoint there. I hit level editor, it goes to that, and then it should call get screen index next, because oh man, that's embarrassing. I just didn't use the right variable. So we should put m next screen index up here on get next screen index, like that. Try not to waste too many times on dumb little things like this. There we go, that's what we wanted. We wanted to crash. Yeah, we can retry, and who cares? We know what's wrong. Alright, so now we need to add our next screen. So let's go into our Solution Explorer here and add a new class. It's going to be, let's go to add class. This is going to be the level editor screen. Level, and we'll just call it editor screen, be concise. We know what it means. Editor screen.h, editor screen.cpp, finish that. And now, to make things really easy, I'm just going to do more copy pasting because that's what I do. And we're going to take this all the way down. We do want an init UI. We do want to check input. And we don't need a camera. Actually, we do need a camera. We do need a window. And yeah, we'll just copy all this and then hack it up as we need to. So, editor screen. And I'm just going to paste that all here, make sure we have pragma once at the top. I just overwrote it. Pragma once. Okay, and for the includes, I'm going to be extra lazy and again just copy all of this, even though we absolutely don't need all of this, I'm pretty sure. It's no problem. Editor screen, paste it. Okay, now let's see, we have all these virtual functions that we obviously still need. This should not be main menu screen, it should be editor screen. And what else do we have? So we have new game editor exit clicked. We do want an exit clicked, I'm sure. We're going to want an exit button on there. We don't need a next screen index because we're only going to be going, for now at least, we're only going to be going back to the main menu. In the future we're going to make it to where we can go into the game and test our level right away, which is kind of cool. We do want a camera, we do want a window, we do want a GUI. Awesome. So now that we have all this, we can create those method implementations using Visual Assist, which most of you probably don't have, but again, it's pretty cool. Here we go. Create method implementations. All of those in the CPP file, and I probably have multiple constructors now because that always happens. Yep, goodbye. Alright, now we just need to emulate what's happening in main menu screen a little bit. So we want to give ourselves that window, so we'll put that here. And we don't need this. Actually, yeah, we do. We do need screen index. We're going to go to editor screen. This is screen index and editor. Okay. Get next screen index. We're just going to return for now screen index no screen. And for the previous index, we're going to go back to the main menu. Main menu. That's good. Now build, we're not doing anything. Destroy, we're not doing anything again. On entry, we'll do the same thing. We'll init that camera, then we'll call init UI. Nothing special going on here. On exit, let's go ahead and clear the GUI, just like we did in the main menu. Update function, same thing. Update the camera, check the input, super simple. Draw is also going to be exactly the same for now. It's going to be different later once we add some more stuff, because we do want to be able to render all the different boxes and things on the screen here. Now for init UI, we'll leave that for now. For check input, we'll do the same thing. We just pass in all the input to the GUI. And on exit clicked, we're going to do the same thing. Exit application, return true. Alright, so for the init UI, one thing we do need is we do need all these initialization things right here for setting up the GUI and giving it a look and feel, which we're using this Tazarek look, which really doesn't look that great, but that's what we're using. There we go. And we're going to use that Deja Vu Sans 10 font. And alright, so now all we got to do is, let's go ahead and do the same thing down here. Use our custom cursor, just because that's what we've been doing. Want to be nice and consistent. And now in here, this is where we're going to actually add some of our controls. But for now, let's just go ahead and hook up this editor screen with our app and make sure that it's all going to work. So we're going to say editor screen equals this whole mess right here, except instead of a gameplay screen, we're using the editor screen. Like that, and we're going to add that screen with editor screen.get. And we're still starting with the main menu screen, so that stays the same. And in app.h, we want to make sure we declare our little unique pointer here. And editor screen. Alright, so now this should all work after we include the file. Include editor screen.h. Alright, so let's run it. Hopefully we don't have any build errors. And it looks like we don't. Got lucky that time. Alright, so here we are. Now when I click Level Editor, it should take me to a blank page. There we go. We have a blank screen with a blank background. Nothing to click on because we haven't added any controls, but this is our level editor. This is where we can put all our level editor stuff. So now we can come back to the editor screen, and we need to actually add some controls. Let's start with the easiest one. Let's go ahead and add an exit button, and we'll just put it at the top right, which is a weird place to put it, but I mean, really, we don't even need an exit button. We can just click this X up here, and it should work. Oh no, we never hooked that up either. So let's go ahead and do that. Instead of using an exit button, we'll just hook that up with SDL. So this is actually really easy to do, and we can just copy paste what we do to this to the other screens. We're just going to, after we pass that into the GUI, we're also going to do our own little custom parsing on it. We're going to say switch event type, and the type we care about is case SDL quit. That's the type of event that runs whenever you click that quit button at the top right. And we already have a handler for this that we were using for the GUI to quit the game. We can just reuse this code. So what we can do is we can just say on exit clicked, and it wants some args, but we're not even using those args, so we can just pass in some temporary args, CEGUI event args. Yeah, just and then parentheses there, and that'll just create some temporary args and pass them in. Now your compiler, depending on what it is, I believe Clang might complain about this, saying that you're creating a temporary variable and using its reference when really this isn't a problem. If that's true, just declare it out here and then pass in the temporary event args like that. But this, for me, this is going to work, so I'm just going to keep it like this. Okay, so now let's test that and make sure it does work for our editor screen, and if it does, we'll just quickly paste that to all the other ones. So I click quick, top right, exits the game. It's perfect. So I'm going to take this, put it in main menu screen, and that's here, check event, and I'm also going to put it in gameplay screen, and oh, I didn't do the switch. Got to grab all of it, including the switch here. Main menu screen, paste that, and then gameplay screen. I believe we have an on-exit event in gameplay screen. Yeah, we have an on-exit clicked as well. Check input. There we go. And on exit click there. So now we can quit the game with the X button from anywhere, which is pretty nice. I'm not sure why I didn't add that before. Now we have the exit button at the top right. Now let's go ahead and add some other helpful controls. We're going to want to have a color picker that lets us actually pick what color of the blocks. We're going to probably want some checkboxes maybe for like setting if it's a rigid body or if it's something that can actually move around. Let's see, and eventually we're going to also want the ability to probably load a texture and apply that to our objects and things like that. So for now, let's just start with the color picker. Now the way I'm going to do the color picker is I'm going to create 3 sliders for the R, G, and B values, and then when you move those sliders, it'll update a little color picker kind of square so that you can see the changing color, and then we'll also be storing those variables in editor screens so that whenever we do decide to create an object, it'll be the right color. So for the color picker, now I don't believe we've actually used it. I think we only used in gameplay screen.h, we've only used buttons and yeah, we've only used buttons and the combo box. So what we want to do is instead of using a combo box, we're going to use a slider, and the slider is exactly what you'd expect. It's a slider. It lets you pick a number between a range of numbers. So let's go ahead and create ourselves a slider, and we're going to be hopefully using the TazRec/slider here. We'll have the TazRec/slider. I'm pretty sure it's in there, but if it's not, we'll have to possibly use a different look and feel. So we're going to go back to our editor screen, and we're going to start creating it. So we're going to say CEGUI : slider. This will be star, and this will be our slider for red, equals static cast, and we're going to cast to a CEGUI slider. And we're going to use our GUI to create the widget, so we're going to say mGUI.createWidget. And we're going to pass in the look and feel first for the type, and that's going to be TazRec/slider, hopefully. We'll find out. If it crashes, then we need to pick something else. And then we're going to say for the destination rectangle, we're going to use the GLM vec4. And let's do for the X position, we'll say just like 0.05. For the Y position, we'll start at 0.05 and see what that looks like. And for the width, let's do 0.2. And for the height, let's do 0.05. Let's just see what this looks like. There we go. And then it also wants another DeskDirect in pixels, but we're just going to default this to 0 because we want our little application to work for pretty much any resolution. It won't work for any resolution, but it should look good on a lot of resolutions. And we're going to call this red slider. There we go. So that should create our little slider. Now let's see if it renders, and let's see if we can actually drag our mouse cursor around. And drag the slider around. And we got a failed error. I'm missing a paren. There we go. Put it right there. Okay, now we run. I believe I did that right. Oh no, I did not do that right. Okay, so the issue is actually really simple. TazDirect look has a capital L here, and then that will work. Now also I was Googling it, and the TazDirect look slider, it's only designed to be a vertical slider, and I was thinking that we were going to do a horizontal slider. Now we could use a different look and feel to use a vertical slider, a horizontal slider, or we could go into the TazDirect look and feel file and edit this to be able to do to be able to be horizontal. I believe what you do is here, instead of vertical slider, you change this to false right here. And you also do, let's see, you need to go, there's a vertical scroll thumb, slider thumb. And yeah, this is it in slider thumb. We have to change this to horiz 3. Horiz free. I just found this Googling the exact issue. It was pretty easy to find, so you can look into this. Instead of doing this though, because if I do this, the actual image is designed for vertical and it'll look kind of bad. Instead, I'm just going to say that we're going to use vertical sliders instead of horizontal sliders. I'll show you how bad it looks right now, just because I thought we were doing a horizontal slider, but it's actually vertical. If I run it with this and I do level editor, here's our slider. As you can see, I can slide this little thing up and down because it's vertical. So let's go ahead and change that. Let's go into where we defined our slider here. So X and Y are going to be the same, but we're going to flip the width and height. So this will be 0.05 and this will be 0.2. Now let's also set the minimum and maximum value. Now the minimum is always for sliders in CEGUI. It's always fixed at 0. Which is good for us right now. All we need to do is set the maximum to 255. So we're going to say our slider dot set max value, and we're going to set this to 255.0f. And let's also set the current value. Let's say our slider set current value, and we're going to set this to whatever our current red value is, which we're going to default to 255. I'm going to go into the header file here, and we're going to say float color picker red equals 255, and we'll do this for blue and green with an F on the front, maybe. So we have red, blue, and green here. Our RBG, no, let's do the right order. Let's do RGB. Not that it matters. And all right, so we have red, green, and blue. So we're going to say current color red, because I did it wrong and forgot to put the M at the front, not following standards. There we go. Current color red. No, color picker red. Color picker red. There we go. So we're going to set the current value to that. So it should be all the way, I believe, down, or is it all the way up? I don't know. We'll see. Why are you complaining? M color picker red red. There we go. So now we should have a value that is set to 255, and we can scroll it between 0 and 255. We won't be able to see what the value is, but here's our, wow, I really do not like the look of this slider. It is a very ugly slider, but I'm going to leave it to you guys to make it pretty. I mean, you guys can modify the images and go into the TazDirect look and feel. Like if you go into that file, you should be able to find where it's using the image. Like we have image name, it's in here somewhere. You'll be able to find it. and then you'll be able to change that if you care enough. Or you can just make your own look and feel, obviously. Let's make it a little thinner because I think that is way too thick. Let's make it way thinner. 0.15. Let's see what that looks like. I'm going to run that, and level editor. That is reasonably better. Now it's too tall, so it doesn't need to be 0.2. We can just make it 0.1. And I think it should look a lot better. So now we have the R slider and the G slider, or we have the R slider. We need to make this G slider and the B slider. Let's add a comment, add the color picker. And one thing that's kind of neat, if we're kind of making this like just a mini procedure, it's going to do all our color picker stuff, and it's going to have its own variables in here that only need to be scoped for this. They don't need to be called outside of this color picker logic that we're going to do. So if we want to, we can actually just put a scope here. We can just, as if we were doing an if statement. And that's just going to scope this. That's just going to make it so if I was to come out here and try to say R slider dot set max value or something, it's not going to let me. It's going to say it's out of scope. That's all it's doing. It's basically saying this is a mini function, a mini little procedure kind of. That's how we can logically think of this inside of init UI. It's kind of a way that you can clean up your code a little bit. I just don't abuse it too much. I wouldn't nest this because it'll get really confusing. I would just use it for very simple stuff like this. Okay, and in here we can make our own variables that are only defined for this, which is kind of nice as well. So let's actually do our dimensions in here for the x dimensions and the y dimensions. Const float xdim equals 0.015f, and let's do ydim equals 0.1f. And we'll just paste that. Much better, so now we can kind of reuse that, which is pretty good. And since these are vertical sliders, they're all going to have the exact same y position as well. Float y pos equals 0.05f. They're just going to have differing x positions. There we go. And so we have the R slider. Let's do the G slider and the B slider. There we go. G slider, B slider. This is all the same. Red slider is going to be green slider and blue slider. Green slider, blue slider. There we go. Color picker green. Color picker blue. There we go. And set max value is going to be 255 for all these. So now let's change this. So this is going to be, we'll say 0.05 plus, and let's add the x dimensions plus some padding value. Let's give ourselves a padding so we can control the spacing. Const float padding. And see, now that we have this scope, we can also use a padding variable outside and not worry about conflicting names or anything like that. Let's just pad with 0.02f in between each slider. So we're going to say plus padding. And then we'll do the same thing here, except the xdim plus padding is going to be multiplied by 2, since this is the third slider. There we go. So now we should have 3 unique sliders. Let's go ahead and see if that works. There we go, and we have 3 unique sliders, but I didn't set the values right. And let's also reduce the padding a bit. That's a lot of padding. Let's do 0.05. And yeah, I did R slider instead of G slider, and R slider instead of B slider. Another problem with copy paste. So let's run that. Okay, great. So now we have our 3 sliders. Looking good. Now what I would like to do is set the color of each slider to be a different color. So the R slider would be red, the G slider would be green. But unfortunately you can't do that. There's no set color value for CEGUI, one of the downsides. But if you wanted to do that, what you could do is make a new look and feel for each. You could like copy paste the Tazerac look and feel and use your own image and your own colors. Like here we have colors right here. You could probably modify that for each one. But instead of doing that, I'm just going to be lazy and leave them all the same color and just have the visual little color picker square that's going to change colors for us. Because you guys are smart enough to do this stuff. There's no need for me to do that for you on camera. All right, so we have R slider, G slider, B slider. Let's actually make them modify a value. So we can actually set up an event that runs whenever the sliders move. And there's the event is called, I believe, the what is it called? I don't remember what it's called, but it doesn't matter. We'll figure it out. So what we're going to do is we're going to do our same subscribing event code. We're going to say our slider, and it's going to be subscribe event. And then first thing we do is say what the type of event is, and it's going to be CEGUI, and it's going to be slider, : : Now it's not showing up for you because I don't have Arrow desktops set up, but I have a box that's dropping down here. You should too if you have IntelliSense enabled. And I can type EVENT for event, and there's several events, and I want, I typed it in wrong. Event value changed. There it is, event value changed. That's what I want. And then we also have to have a subscriber, CEGUI event subscriber, and we're going to pass in a function, and we'll call it editor screen : we'll say on red color picker red changed. Red changed. That sounds nice and verbose and good. So we're going to say this for the object we're passing in. So we don't have this on color picker red changed, but we will. We'll do the same thing for G and B, and we're going to use green and blue obviously instead of red. Green and blue. So let's go into editor screen.h and give ourselves the events for that, the event handlers. So on color picker red changed. There we go. And we'll do the same for green and blue. Easy enough. Green and blue. And I'm going to grab all three of these and dump them in our CPP file. Put editor screen in front of all of them, and then put some braces after all of them. Alright, so now that we have this, we'll just go ahead and return true in every case. So here's where we're actually going to be using some event args. This is going to be the first time we actually use those args. Oh wait, no, actually I lied. We are not going to be using the args. Another thing about CEGUI, sometimes the arguments that are passed in are not what you want. It's just kind of how it works. I have the CEGUI event reference here. You can Google it. It's really easy to find. The slider event value changed here that we're using, it takes window event args. It doesn't have anything about the value. So what we're going to need to do is whenever we get these functions to run, we're going to need to query the value from our slider. However, our slider is here, the pointer, and then we just kind of get rid of it. So instead, let's go ahead and make these sliders some member variables up here. So we'll say mRSlider and mGSlider, mBSlider. And for safety, let's set these to null pointer at the start in case we get some weird problems later. We'll easily see the crash. RGB, there we go. And then down here, instead of creating a local slider, we're just going to use our member variables. MG, then MB, and since we are passing the this pointer whenever we do our on color picker change, we are going to have access to all of these. So all we got to do is get our slider value. So we're going to say m current color or color picker red equals, and we're going to say m our slider get value. Get current value. Now if we wanted to, we could just completely get rid of mColorPickerRed altogether and just always use this, but I feel like doing it this way, so that's how we're going to do it today. mColorPickerGreen is GSlider and mColorPickerBlue is BlueSlider. And if that was the case, we wouldn't even need these event handlers probably. We would just always query using getCurrentValue. So now we have color picker red, green, and blue that are going to run every time we change the value of our little events. Now we want to make sure that we are changing our color value with a tick rate of 1. I forgot to do that. So that we go from 0 to 1 to 2 all the way to 255, and we're not changing to like 0.05 or anything like that. We're going to say mSlider set tick hang on. Okay, it is set click step. Rather strange name, but that's what it is. And we're going to just say 1.0f is the click step. That's the resolution of our slider, essentially. I think click step is a weird name, but I'm not going to complain. So now we're going to run, and it should, I mean, we're not going to see anything happen, but all this stuff should happen. I'm going to go ahead and put breakpoints to make sure that whenever we do modify the color, it happens. So this should break once immediately because we're setting the value. Oh, maybe not. So what was the one I put the breakpoint in? I put it in blue. So if I do that, there we go. We get a color change there, which is good. There. So now we have our color picker red, green, and blue. Now what we want to do is use our Sprite Batch, which we don't have a Sprite Batch up here. We want to use a Sprite Batch to render a quad that has color with our RGB color picker thing so that we can actually visualize the color that we are creating. So we need a Sprite Batch, and I don't believe, I guess we need a texture program, and what else do we need? We'll need a blank texture because our Sprite Batch isn't configured to work with no texture, I believe. And yeah, that's it for now. So editor screen, dump that stuff here, and ooh, we're also going to want a sprite font. I know we're going to want that. Why don't I have a sprite font up here? I thought I was using font, I guess not. So let's go ahead and get a sprite font. Oh, I taught sprite font, didn't I? Of course I did. We just have to include it. Include bingen sprite font.h. It's weird my IntelliSense isn't popping up like it usually does. Bingen sprite font, there it is, m sprite font. Now we need to make sure we're initializing all of this stuff in our CPP file, so let's start with the Sprite Batch editor screen, and we're going to say, let's do on entry, we're going to say Sprite Batch dot init. There we go, and I believe, do we have a destroy? We should have a destroy. We don't, but whatever. And we also need a sprite font.init, m sprite font.init. And I believe, if I'm not mistaken, oh, is there no init? What does our sprite font do? I always forget. We pass in a, oh, we have to use the constructor. Oh, that's really dumb, but this is the way I designed it, so it's only my fault. Well, I guess Christian kind of designed it this way, and then I copied it, but we need the font and the size to be passed into the constructor, which means we can't declare it like this unless we are then in the initialization list for our editor screen setting it up. So we'll go ahead and do that. I'm going to say m sprite font. Now the font file, I believe we have a really ugly font to look at. So let's go to projects, graphics tutorials, and then Ninja Platformer. I think we're going to need to copy it. We should have a fonts. Here we go, Zombie Game fonts. Yeah, we have this really ugly chintzy font. I'm going to copy it from Zombie Game and paste it in Ninja Platformer. I guess we haven't used font yet. So we're going to be grabbing fonts/chintzY.ttf. Fonts/chintzY.ttf. Terrible, terrible font. 32 for the size. And there we go. Now we have our sprite font initialized, so we should be able to use font. And we have our Sprite Batch. Let's also do the shader. Excuse me. So what was it? Texture program dot, and then we have, what is it? Compile shaders from source, or we can just use compile shaders. We're just going to do compile shaders and give it a file path, I guess. I think we already have a shader file in here. Shader, yep, texture shading.frag. So we'll just grab that. We're going to say shaders, texture shading.frag, and actually we can just probably copy this all from gameplay screen. We're doing the same thing here. There's mlight program. Where's mtexture program? Here we go. We're just going to grab all this shader in it because it's the exact same thing. And tell me we can destroy the shaders. I hope I set that up. Dispose. Dispose, destroy. Alright, so we have our shader, we are linking the shader, Now we want to actually draw that color picker. So in our render function, we'll draw it before we draw the GUI. Draw the color picker quad. Now I think we're going to need to also load a blank texture, or just initialize a blank texture as well. So for the color picker quad, we're going to say m sprite batch dot begin, m sprite batch dot end, m sprite batch dot draw, and the destination rectangle we're going to be getting from our, let's just draw it off to the right of our last slider, which is the B slider. So we'll draw it off to the right of that. Here we go. So we want glmvec4 dest rect. I'm going to do this little magic again. We're going to put some scope so we can use dest rect multiple times if we decide to. So dest rect.x equals mb slider get position x, get x position. And this is going to be, so it's a udim, so we have, I always forget, we have udim, and we're going to do pixels. We're going to use the absolute pixels. Dot, is there a dot? I think we just say dot pix. Oh man, I don't even know. That looks like it's going to work. So destrect x equals that, destrect y equals that, get y position. And then for the width and height, well, first let's just add an offset. For the x, we'll do plus 20, just random. We'll fix this up after we get it actually rendering on the screen. Rect.z, we'll say 50, and we'll change this to a constant as well, 50. Alright, so now we can pass in destrect. Now we need a UV rect, and we're just going to do glmvec4 0 0 1 1. For the texture, we need to set that up still. For the depth, we'll just use 0, and for the color, we'll say white. We definitely want it to be, no, we don't want it to be white. We want it to be the color that we are currently, our current slider color is what we want. So we want color RGBA8, and we're going to be, for R, it's going to be M color picker red. For G, M color picker blue. For B, M color picker green. For alpha, always 255. And it's actually taking GLU byte. And these are floats. Luckily, we can, since these are floats that we are pretty much guaranteeing to be 0 to 255 and always a whole number, thanks to our tick rate, we can just go ahead and cast these to GLU bytes. I believe this is going to work. Now, if you would stop complaining, Benjin, color RGB8. Here we go. So now all we need is the texture. So we're going to need to load in a blank texture. I believe we've already used a blank texture before. I want to see Ninja Platformer, Assets. No, we don't have one there. Graphics Tutorials, Textures. Let's try that. No, nothing there. Okay, I'll just pause the video and make one real quick. Okay, I just made a 1 pixel texture that's just a white pixel called blank.png. Alternatively, we could just, and really objectively the better thing to do would be to not even load this in and instead just construct our texture in memory. But this is easier. I mean, you guys don't need me to teach you that. That's pretty basic. So let's go ahead and set up our texture. So we'll have a blank texture, GLUint, I believe, m blank texture. We'll find out. And we're going to start that out at 0 just to be safe. And then in the CPP file for editor screen and on entry, we're going to load it. I believe it's resource manager : get texture. Now the texture path is going to be, I don't know, it's going to be assets/blank.png. Assets/blank.png. I did a lowercase, right? Yeah. And then that's it. We're just going to do that. So we're going to say mTexture, mBlankTexture equals that. And that'll load our empty texture. and it should be Benjin : resource manager, and I need to include it, I'm sure. Yeah. Include Benjin. Where is it? Is resource manager. Okay. My IntelliSense isn't really working for these includes for some reason. There we go. What's the problem here? Oh, because it returns a GL texture, so we want to use that instead. Benjin GL texture, blank texture, and we'll set that right there. Cool, now we have the texture, so we can pass it in. We can say, I believe this just takes the ID. Yep, it just takes the ID, so we'll say, whoops, we'll say blank texture ID. Alright, so now that should work. Let's see if we get something on the screen. Let's run the debug. It should be a white square. Oh no, what do we got here? Alright, let me actually find out like how this works here for a second. Okay, I did my research. So what we want is the .d offset, or sorry, descale. That other function, this pix function, is actually a static call that just returns a constant thing. You don't want that. So there we go, we get descale, and this is the scale that we passed in down here. It's that number between 0 and 1 usually. That's going to be a percentage of the window dimensions. So if we want to get the actual pixels, we have to just multiply by the window dimensions. So we're going to multiply by window get screen width and screen height for this one. Height. There we go. Now, so we're doing Sprite Batch.draw and all that. We also want to do a render batch. So we'll say Sprite Batch.render batch. There we go. And also we need to make sure that we are binding our GL program and all that and setting up all the uniforms. Luckily we can get that from gameplay screen since we already did all that there. So we'll say we have texture program use. And remember, if we wanted to, we could have separate renderers like we learned in the ball game and really clean this stuff up. But for now we're just doing it the quick and dirty way because, you know, why not? We're going to grab all this stuff, let's see, and then we're also going to need to remember to unuse the program down at the bottom. So let's grab this and paste it. It should all work just as is, and then we're going to say Sprite Batch, no, sorry, program, texture program dot unused down there just for safety. So now we're going to render it to the screen. We should, and then we're going to be, let's see, there's going to be a problem though. So if we run it, we should render it. We shouldn't get a crash or anything like that, but we won't be able to see it. And it looks like I'm missing a paren here at the end of that. There we go. When we run it, we're not going to be able to see it because of our camera, and I'll show you why. There's a few reasons. So first of all, it's completely gone. We don't see it anywhere. The reason we don't see it at all is because if we go up to this code that we copy-pasted where we set the scale, we were setting the scale to 32 pixels. We need to set it to 1 pixel. So each pixel here is 1 pixel on the UI and all that. So it makes perfect sense. So now we run it, we should at least see the quad. It's going to be in the wrong place though. So there we see the quad, but it's way over here. That's because 0 is the origin for our camera. That's what we decided. But for the UI, the origin is up at the top left here. So all we got to do is do some subtraction of the window dimensions. So if we go here, we're going to subtract the window dimensions for the width divided by 2 and the height divided by 2. And that should put it in the correct place. Screen height. There we go. Now it's going to be still in kind of a weird spot, I'm sure, because we haven't done any tweaking. There we go. So, oh, and I need to invert it. So actually, let's add for the Y. We'll add Y, since the dimensions are inverted in the Y direction, apparently. That's fine. And, oh, it's gone, probably because it's up here off the screen. So now let's just, let's do some little tweaking. Let's subtract with some more position stuff. Let's say B slider, we'll subtract for the Y, we'll subtract B slider, get height, there we go, get height.descale times window. This is getting to be a really huge, disgusting line of code. There we go. Alright, so now we're subtracting the height. Let's see where that puts it. I think we're going to want to subtract the height divided by 2. No, we're subtracting the height and it's putting it right there, which is what we want. So what we actually want to do is subtract the height times 1.5. So we're subtracting the height and then moving it down again by half. So times 1.5. This is so janky, but it's going to work. There we go. Now that puts it here. Now we want to move it over a little bit more. Let's add more than 20 pixels. And we also want to move it down by half of the size of the quad. So our quad size is 50. Let's make it constant. Const float quad size equals 50. So let's move this over to a new line. Minus quad size divided by 2. Alright, and for x, let's also add quad size divided by 2, in addition to that 20 pixels of padding. So now if we run it, it should, oops, I need a semicolon there. It should kind of look like it's in a decent spot, like it should be centered and everything, if I'm not mistaken. There we go, it's centered to the right. Cool. This is good enough for me. Now let's see if it works. So all of these are at the top. It should be white as it is. So let's make it magenta. Let's lower the green. Actually, RGB. That's weird. Let's see. I think our color pickers are messed up. Oh, so this is green. This is blue. RB. This is R. So we're RBG instead of RGB. Let's fix that. On green, color picker green. On blue, so what are we doing here? Color picker green changed. Color picker blue changed. RGB. Why is the last one green? Am I crazy? Maybe I'm crazy. No, that's definitely green. The last one is green. I must be doing something weird when I draw it. Yeah, I did it wrong here. RGB, not RBG, in Sprite Batch.draw. So now we should have the correct color picker stuff here. Level editor, there we go. We've got a color picker. Awesome. So if I want to make it magenta, I can do all red and blue. That'll give us magenta. I can do blue, I can do green, I can do any combination. You could also use sprite font to print out the color if you want the actual color value shown. You can do that as well. Just do what you want. I'm going to actually make this a little bit bigger. Instead of 50, let's make it, where are we? Here we go. Instead of 50 for quad size, let's make it 75 and see how that looks. And then we'll move on. There you go. I like the size of that. Nice big color picker there. Okay, so now we can select colors. We're not going to do anything with that really in this tutorial right now. We're just kind of setting it all up, doing all this boilerplate stuff. So what else do we want? We want to be able to create some objects, don't we? So let's go ahead and add some checkboxes for that, for the type of object. So what we're going to want to do is use radio buttons that'll let them pick if they want a rigid mode for things like platforms that don't move, or if they want a dynamic mode for like those boxes that fall down. So let's create an enum up here. We'll say enum class, we'll say physics mode. And we're going to have rigid and dynamic, like that. So we'll have a physics mode set down here. Physics mode M physics mode. And we're going to set this, we're going to start this at physics mode, we'll say rigid. We'll default to just a rigid mode. That'll be good, and let's go to the editor screen and actually give ourselves some radio buttons for that. I think I know what it is, but I could be wrong. So here's for adding the color picker. Let's do add the physics mode radio buttons. And again, our UI is going to be very disgusting. It's not going to be pretty, but it's going to have utility, which is all I care about right now for showing you guys this stuff. So we're going to say, what do we want? We want to, let's see, CEGUI radio button. There we go. It does exist. That's good. Let's go ahead and store these in our header file like we did with all of the other controls here. We're going to say radio button M. We'll say rigid radio button, and we're going to do dynamic radio button. That's good. So let's do that. We're going to say create widget with all this stuff. We'll do something similar. So GUI, create widget, and Taharez look radio button. I hope that exists. We'll find out. If it doesn't, we'll use something else. Now for the positioning, let's do glm vec4. Vec4. We're going to do for the X position, we'll just start at 0.05. For the Y position, let's set ourselves a Y pos again. So we're going to copy this. Let's set the Y pos for like 25% down the screen for now. Y position, and these are going to be squares, so const float dim is we'll say 0.05. We can change that as well. Dims. And then again, the pixel one is just 0. We're going to make everything relative. And this one's going to be called, we'll say, rigid button. There we go. So we have our rigid button. And we also want, well, we have to store it, of course. Rigid radio button equals that. And we also want to create the other button, the dynamic one, which is going to be similar. Dynamic radio button, and this will be rigid button, this will be dynamic button, and I forgot parentheses again, like I always do. There we go. Now for the X position, we're just going to add, we'll add dims plus some padding, and our padding will be small again. So the padding will be about the same as it was. So let's just see if we get this rendering. Let's try that out. We should see two radio buttons. Now they're not connected to each other in any way, so they can both be active at the same time. There we go. We have two radio buttons. I can even click on them. Oh, and it looks like by default, CEGUI is going to make it so that these radio buttons in this GUI context are linked together, which is kind of nice, so we don't have to do any setup for that. That's pretty neat. But it looks like they are way too far apart. I think I set that to be a little bit too much. What did I set the padding? What did I set the dims to be? And that's kind of weird that it's so big. What if I get rid of the padding? Where does that put it? Well, I'm not really sure why it's so far away. That should put them really close together, but let's see. That's really weird. I think there might be something weird with the look and feel for these things. I think they might be bigger than that image actually shows, which is a bit troubling. But we're not going to concern ourselves with this right now. Let's just put it back the way it was. We'll run it, and then we'll click on both again. So if I'm not mistaken, I can click outside of it. Yeah, look at that. So the actual... that's so bad. Man, I would think that... Man, that's... Look how big these are. If I click really far away from it, it'll activate it because the image is really small, but the actual bounding box for these things, at least in the X direction, it looks like it's pretty darn big. Could that have had to do with the way I did the look and feel? Now there's... Oh, yes, actually. Because the dimensions here for the button, this is actually, I think, my fault. The way the look and feel is going to work is it's always going to render them as circles, it seems like. It's not going to stretch them. But I'm making them, even though these dims are the same here for the percentage, because our Windows aspect ratio isn't 1:1, we're going to get weird values here. So actually, instead of using these dims like we did before, we're going to actually make use of the pixels field over here for dimensions. So we're going to actually specify that they are the exact same size in pixels. So dims pixels, we're going to say they are 20 pixels for now. Alright, and 0.0f, dims pixels, for the dimensions. Cool. Now if we run it, it should do what we want. Ideally. What do we have here? Oh, right. I have to do the same thing here. Dims pixels, and we're going to say plus, for now we'll just do plus padding, and they're going to be kind of wrong, but that's alright. YPOS 0, 0. There we go, let's run it. And we should get our two radio buttons. There we go, and they're like right on top of each other now, but now I'm actually able to click them individually. They don't have those huge stretched bounding boxes. Let's do the padding. Let's just hard code the padding to be 0.5. I don't really mind too much about this. There we go, and well, that's way too big, but it works now. We have our radio buttons, so now we need to hook up our radio buttons. So let's do that. We need to make it so that whenever one of them is active, we are properly reflecting that in our Boolean. So right now our default is rigid, so let's select the rigid one by default. M rigid radio button. I believe it's set selected. Yes, set selected is going to be true. So this is going to be selected to true. And just for safety, even though I don't think we actually need to do this, let's set the selected for dynamic to false. And now we can hook up our event handlers for this. So we can do a subscribe event. I'm going to just copy this subscribe event like that. And this is going to be radio button event select state changed, or is there an event clicked? Event mouse click should be good. I think that should actually change our selected state, which is good. Alright, so if event mouse click runs, we're going to want to run a function. We're going to say on rigid mouse click, and then for the other one, for the dynamic button, and this should be not MG slider, this should be the radio button, we're going to say on dynamic mouse click. So let's create those functions. We'll just copy this. On rigid mouse clicked. On dynamic mouse clicked. I'm going to put these in the CPP file. And, yep, put them right there. And so what we're going to do is return true for both of these. And then when we click the rigid mouse clicked, we're going to say m current, or we're going to say m physics mode equals physics mode rigid. And for dynamic mode, we're going to say m physics mode equals physics mode dynamic. So I'm going to put a breakpoint here, and we're going to see that we can hit that whenever I click the dynamic button. Now we're going to want to put some text above these, of course. We can do that with Sprite font. We have an error list. Clicked. We'll rename it to click. Makes more sense. Click, click. Click, click. Run. Here we go, level editor, and if I click this, we should get that event handler. There we go. That's setting our physics mode to dynamic. So if we were going to then go place an object on the screen, we could place it to be dynamic. So let's try rendering a little bit of sprite font text, and then we're going to end this video after that because all this stuff, I've taught you a little bit of new stuff in this, but I think the next thing I'm going to do is maybe add a couple buttons, and I really don't think I need to do that on camera for you guys. Maybe I will, maybe I won't, but I want to cut this video short because it's getting kind of long now. So what we want to do is go to init UI. No, we actually want to go to draw, and we just want to draw it where the rigid radio button is and where the dynamic radio button is. So this is draw the color picker quad. This is going to be draw labels for rigid and dynamic buttons. So we're going to say we want to do pretty much the same thing here. We're going to call, let's actually share the Sprite Batch begin and end like that. Move these out. that's what we want. Alright, so for drawing this, we're going to call Sprite Batch draw. Where's there Sprite font draw, and then we pass in, yeah, that's how it works. Then we pass in Sprite Batch to that. That's how it works. Now we need the string, we need the position, we need the scaling, we need the depth, all that. Now for the string, for the rigid one, we're going to say just rigid. And for the dynamic one, we're going to say dynamic. But for the position, we need a glmvec2. Position. So the position.x is going to be equal to the, we'll say, it's going to be it's going to be radio button rigid radio button dot get x position descale times the screen width, and for y, I'll come back and modify this after we see how it looks, times screen height, and this is get y position. Pos scaling, let's just do 1 for now. We're using 32-point font, so it should be about 32 pixels per letter. For the depth, just 0. For the color, we're going to say Benjin color RGBA8. We're going to just do white. Should that work? Hope that works. Did we set up that constructor? Of course not. Would have been convenient, but that's not what we did. Now for the justification, let's definitely do middle justification. That would be great. And alright, so that's going to draw for the rigid, and then we want to do it for the dynamic as well. So dynamic, and this is going to use dynamic radio button. Now I think what we want is, we want the x, oh geez. We want the x to be the same since we're doing centered justification, but we want the y probably to be different. Let's just see how this looks. And oh, I forgot we need to subtract. We need to subtract the size here. We want to do minus screen width divided by 2, and minus screen height divided by 2, or plus screen height divided by 2, because it's inverted again. Remember that. And let's see what that looks like. They're still going to be overlapping each other pretty badly, I think. Well, that worked for dynamic. I forgot to do it for the other one as well. So that worked for rigid, I guess. Minus screen width divided by 2 plus screen height divided by 2. Okay, after much trial and error, I figured it out, and we're actually wrong on both of these, so you have my apologies for being wrong again. What we want is, for the y, we want screen height divided by 2 minus this, and screen width divided by 2 minus this. Same thing up here, so we were doing this weird thing here where we like added this screen height divided by 2, what the heck, I mean, so instead of this plus screen height divided by 2, we're going to say screen height divided by 2 minus this position right here, and I think that'll work. It'll at least work for the fonts. There may be some weird thing with this times 1.5 down here. Yeah, so this, what is this? Let's just minus 0.05. There we go. There we go, now it's in the right spot, and let me test it by moving it down. So let's increase the padding between the radio buttons first of all. Let's increase the padding to 0.4 so that we can see the text. And then let's move down the color picker really far so I can make sure. We would notice the box moving, kind of shifting if we did it wrong. There we go, it's in the right spot. And here we have rigid and dynamic. Still need to move them a little bit further apart, or we can just shrink the text. I guess I'll just shrink the text. So we're going to move this back to 0.5 again, now that it's working. And then when we draw the text with the scaling here, let's just say scale it down to 0.5. So half-sized text for rigid and dynamic. And we should see our little radio buttons with nice little headers above them. There we go. Rigid dynamic. 0.5 was probably a little bit too drastic, so let's change it to like we'll say 0.7. Now I think we also want to maybe add half of the width to the rigid and dynamic labels. If you wanted to, I think it's kind of off-center. I think it's centering around the left side of the button. That's exactly what it looks like is happening. So what we can do is add the pixel width divided by 2 if we want to center that. So we're going to add for the X, for say plus M rigid radio button get X position dot D offset instead of D scale. D scale is when you were using these the scale as sorry, the window scale like we were doing here. Pixel is whenever, or sorry, offset is when you're using this parameter with the pixels, which we are using for dimensions. So we will be using that offset value instead of the scale value. So where were we? Plus D offset divided by 2 should be good. If we do this for both the rigid and the dynamic button, it should look centered. It should be dynamic radio button. And we don't need 2 semicolons, just 1. So let's see if that looks correct, like I think it should. Hopefully it does. There we go. It's a little bit more centered, I guess. It doesn't look like it's still that centered. What if we, instead of dividing by 2, unless D offset is 0, that could be the case, that D offset is just 0 for some reason. Quite possible that I don't know what I'm talking about. Yeah, it looks like D offset might be 0. So we may have to use D scale. Let's try D scale. Oh, because I did X position. Should be get width, not X position. Dot D offset divided by 2. And get height. Dot D offset divided by 2. There we go. I've got you guys doing the wrong thing over and over again, and for that I apologize. There we go. So now we have rigid dynamic, we have colors. Now there's a few more things, like we're going to want some buttons to like add controls and things like that, but for now we'll just leave it for this tutorial. I feel like we got pretty far and did some neat things. So I will see you guys in the next tutorial where we will do more editor things.